In this video, we will consider the meaning of equilibrium of forces and what will be the graphical representation of number of forces which are in equilibrium. Suppose a number of forces are acting on a particle, let they be F1, F2, F3 and so on. Now, if their resultant, that is F1 plus F2 plus F3, is a zero vector, then forces are in equilibrium. If a number of forces acting on a particle are in equilibrium, then acceleration of the particle will be zero, which follows from Newton's second law of motion. If net force acting on a particle is zero, it implies acceleration of the particle will be zero. Now, if the number of forces are in equilibrium, what will be nature of the vector polygon? Suppose there are forces acting on the object. Let us say there are three forces acting on the object. Now, if these are the only three forces acting on the object, their resultant is vector R. And if we wish to apply Newton's second law to any object on which these forces are acting, we can say mass of the object into acceleration of the object should be equal to vector R. So in this case, R is a non-zero vector and there will be some acceleration of the object. Now, if we wish these forces to be in equilibrium, then they must act in such a manner that we are able to obtain a closed polygon. Now, when a number of forces acting on a particle taken in order form a closed polygon, then closing side of the polygon will be zero, and hence resultant of such forces is zero, and F1, F2 and F3 will be in equilibrium. Suppose there are a number of forces acting on a particle which are unable to produce equilibrium, and they will have this resultant. Now, if we were to determine a fourth force which can make entire system in equilibrium, then it can be easily understood that it should be a vector which is drawn in the same order as the given forces that can make the entire system into equilibrium. So A, B, C, D. Now if vector AD was representing sum of the forces F1, F2 and F3, then its equal and opposite vector, that is dA, if this is superimposed on this system of forces, then entire system will be in equilibrium, and this vector dA is called equilibrant of number of forces. Basically, it is a single vector which when added to the given forces produces equilibrium. So essentially it will be equal and opposite to the resultant of given forces.